Okay, so when we graph on using polar equations, they're like very circular-esque graphs because we're going around using an input of theta instead of, which goes around in a circle instead of more of a linear graph, like in an XY plane. Okay, so there are different types of uh, polar graphs that we kind of categorize. So a rose is one. It looks like, I'm going to keep trying to draw with highlighter. A rose looks like, it looks like this. It's wow, that's not fancy. Okay. So it looks like a little flower. We have a cardioid that looks like um, kind of like this, a heart-ish. A cardioid is a type of limosome. Another type of limosome is an inner loop, so something like this. And then we have a lemniscate that is like, it kind of looks like an infinity sign. It's like a two-petaled rose. Okay. So we know some things about these polar curves by looking at their equations. So what direction do the limosomes face? So if I have um, an equation that's like a plus b times cosine or sine theta, and the multiplier is 1, and then I'm adding numbers on the outside, or adding or subtracting numbers on the outside, then I have what we call a limosome. These are all limosomes. Okay. So if I have a plus b cosine theta, these are all kind of off center from the middle. So like they could look like this, or it could look like facing this direction. Okay. So I need to know, where is the long part of the graph, and we can do that by looking at what the structure of the equation looks like. So if I have r is equal to a plus b cosine of theta, I'm going to think, when am I going to be able to add these? For what angle am I going to add these two values together? So I want cosine theta to equal 1. So when does cosine theta equal 1? Oh, well, at 0. So that's when theta is equal to 0, the longest part at 0 is going to be equal to a plus b. So let's just make this an inner loop, something like that. Okay, so now I have r is equal to a minus b times cosine theta. So remember, I want to be able to add these together, a plus b. So when is cosine theta going to equal -1? So I can multiply that -1 times -b. So that's when theta is equal to pi. Okay, so on this side, I'm going to do a plus b, and then let's make this another inner loop. Okay, that was a bad one. Okay, something like that. All right. So now I have r is equal to a plus b sine theta. When is sine theta going to equal 1? That's when theta is equal to pi over 2. So when I have an a plus b sine, the longest part is going to be at the top. That's a really bad inner loop. They go through the origin like that. Okay. Lastly, when I have a minus b sine theta, I'm going to look for when sine theta is equal to -1. So I want theta to equal 3 pi over 2. So when theta is equal to 3 pi over 2, my longest point, a plus b, ends up at 3 pi over 2. Okay, and let's make this one a cardioid for fun. Okay. So what are the different, we can also tell what types of limasomes we have by again, the structure of the equation. So if I have, let's see, I have all limasomes here, okay? So if the equation for a limasome is R is equal to A plus B cosine theta, or R is equal to A minus B sine or cosine theta, could be sine theta as well. Okay. So if my A divided by my B is less than 1, we get an inner loop. If it is, which looks like this, so looped out, okay. If my A over B is equal to exactly 1, so like R is equal to 2 plus 2 sine theta, that would be a cardioid. We would have a cardioid and something like, could be upside down, like this. Cardioid, okay? If my A over B is between 1 and 2, it's a dimpled, so it's not quite as pronounced as the cardioid, and it kind of, kind of looks like a peach, like the emoji. So just not, it's like a circle that's been dipped a little bit. Okay. And then if I have A over B is greater than or equal to 2, it's what we call convex. So the dimple is popped out. It's convex. Okay. And so let's make a table, and then we're going to graph these. So that's how we do this, is we look at the key points, so on the quadrant plane or on the quadrant angles, and then we just graph in our values. So first we're going to look at what shape it is. So I'm like, okay, there's a 1 in front of the theta. I have an A and a B. So the shape is a limacone, but I need to know what kind. So A is equal to 2 and B is equal to 3. So A is 2 over 3, which gives me less than 1. So I'm like, okay, this is going to be an inner loop. Okay. So now I'm going to go ahead and create a little table for my R and theta. I'm going to use my quadrant angles, so 0, pi over 2, pi, 3 pi over 2, and 2 pi. I'm going to plug in 0, so 2 minus 3 cosine 0 is equal to, cosine 0 is equal to 1, so it goes to 1. So 2 minus 3 is negative 1. Okay, again, 2 minus 3 times cosine of pi over 2, that goes to 0, so this is 2. 2 minus 3 cosine pi, that goes to negative 1, so 2 plus 3 is 5, okay? And then we have 2 minus 3 cosine 3 pi over 2, that goes to 0, so that's 2. And then back to 2 pi, we should probably go back to negative 1. So 2 minus 3 cosine of 2 pi, that's 1. So See, that's -1. Okay, so we're going to graph these at 0, pi over 2, 3 pi over 2. Oops, that would be pi and 3 pi over 2. So at 0, I'm facing 0, but it's a -1, so I'm going to go back 1. At pi over 2, it's a +2 radius, so I go towards pi over 2. At pi, I'm going to go back 5, 1, 2, 5. And at 3 pi over 2, I go down 2. So the inner loop, and then back to 2 pi, and it's back at -1. So the inner loop starts right here, and it's going to loop around, loops around like that. Okay. So this is also, I'm going to mark our starting point. Our starting point was right here. We have to make sure that we're not always starting at 0, 0 here. And I'm going to draw this a little better too. Okay, let's try it again. Oh, that was bad. Okay, so even though it kind of looks like we start at the dimple right here, we actually start right at this point right here at -1, 0. Okay, and we end there too. Let's graph another one, my A and my B. So 6 over 4, that gives me, that's in between 2 and 1, so this is going to be dimpled. Okay, and then I'm going to be like, which direction is the long side going to be? Well, if I have A plus B, I'm looking for when sine theta is the greatest, so that would be at pi over 2. So it's going to be facing up. No, it's going to be upside down. Okay, so the long side is going to go up towards pi over 2. So R and theta, no, theta is 0, pi over 2, pi, 3 pi over 2, and 2 pi. So 6 plus 4 sine 0, 6 plus 4 sine pi over 2. So at sine 0, that would be 0. So this is just 6. Sine pi over 2 is 1. So that's going to equal 10. 6 plus 4 sine pi, that's 0. So that's 6. 6 plus 4 sine 3 pi over 2, that's -1. So 6 minus 4 gives me 2. And then 6 plus 4 sine 2 pi again is back to 0. So that's just plain 6. Okay, we're going to start at 0, pi over 2, pi, 3 pi over 2. Okay, so at 0, my starting value is 6. So 1, 2, 3, 4, 5, 6. And I'm going to mark this to mark our starting point. Okay, and then at pi over 2, goes up to 10, and then back out to 6. 1, 2. There's no negative values, so it's easy to count. Remember, we're going towards pi, so we walk towards it. And then at 3 pi over 2, we're at a radius of 2, so 1, 2. Okay, so we're starting here. We're going to move towards pi over 2 because that's our next point. Okay, and then we're going to move out towards that point. Our next point is this guy. We're just going to sketch it in. Okay, a little dimple. And that's it for right now. And in a second, we're going to look at a couple different types of common polar curves. Okay.